A very warm welcome one and all. Myself Anugraha Ganesh TG from 2nd MSc Physics, Hindustan College of Arts and Science, Coimbatore. Today we are going to discuss about Einstein's A and B coefficient. So, to derive the equation for Einstein's A and B coefficient, we must know about stimulated absorption, spontaneous emission and stimulated emission. What is stimulated absorptions? Atoms in the lower energy state is moved to the higher energy state by absorbing the external energy. The diagram clearly depicts what is stimulated absorption. Second process, spontaneous emission. Here the atoms in the higher energy state is moved to the lower energy state without any external stimulation. Third process, stimulated emission. Atoms in the higher energy gets an energy from the incident photon and emitted two photons as like a chain reaction. The three diagrams clearly explains the process. Let's derive the relation. So, assume N1 and N2 be the number of atoms in the energy level E1 and E2. According to Maxwell's Boltzmann law, N is equal to N0 e raised to minus E by kT. Then we can write the equation for N1 and N2. N1 is equal to N0 e raised to minus E1 by kT. N2 is equal to N0 e raised to minus E2 by kT. By dividing the second relation and third relation, we get N1 by N2 is equal to E2 minus E1 divided by kT. As E is equal to h nu, let's substitute the value here. So, N1 by N2 is equal to E raised to h nu divided by kT. From the relation, we have the constant K is equal to Boltzmann constant, T is the temperature and E is the energy level. Then let's write the equation for stimulated absorption, spontaneous emission and stimulated emission. We have NAB is directly proportional to N1 into Q, where Q is the heat energy or energy of an induced photon. By removing the proportionality, we can add the constant B12. So the relation becomes NAB is equal to B12 N1Q. Similarly, we can write NSP is equal to A21 N2. Stimulated emissions equation become NST is equal to B21 N2Q. Here the three constants A21, B21, A12 are Einstein's coefficient. Next, let's consider an equilibrium condition, that is upward transition is equal to downward transition. So the equation become NSP plus NST is equal to NAB. Substituting those values, we can derive the equation for Q. Q is equal to A21 N2 divided by B12 N1 minus B21 N2. Then let's divide this relation, each term, by B21 N2. So the equation changes to Q is equal to 1 divided by B12 divided by B21 into N1 by N2 minus 1. Let's substitute the equation N1 by N2 is equal to E raised to h nu divided by kT. And let's mark this as equation 13. Next, let's consider Planck's radiation law. Q is equal to 8 by h nu cube divided by c cube into 1 divided by e raised to h nu divided by kT. The both equation, the previously obtained equation and Planck's radiation law is almost similar. So, comparing the equation, we get B12 is equal to B21 and A21 is divided by B21 is equal to 8 pi h nu cube divided by c cube. These two conclusions are obtained, that is stimulated absorption is equal to stimulated emission, and second point, we can conclude that the ratio of spontaneous emission and stimulated emission is directly proportional to the frequency. So I hope you all understood about what is Einstein's A and B coefficient and the relation between the both coefficients. Thank you.